All right, so today we're up to Chapter 3, Debugging. Now let's take a look at that. All right, so we're going to talk about GDB primarily and a few other tools like Valgrind, but mostly GDB. The most important tool, the one I use all the time. All right. So you can step through a program line by line. You can put in breakpoints. You can put in breakpoints that go on conditions, and you can show the value of variables in it. So follow what's going on with variables to track down what flaws are, and examine the stack frame and see what's going on when it crashes. So it's really very useful. So breakpoints stop execution at a certain point, and there is some kind of GUI version of GDB. I've tried a few of these. I have no use for Linux GUIs in general. They never work very well, and I think just using the command line is better. But some people like graphical tools on Linux. I'm not using them. I have a headless server, so this is not an option for me, and I don't care. The command line tool is more powerful anyway. When you compile your code, if you use the -G flag, it will add debugging information to it, and then you can go by lines of source code and refer to variables in the source code. Otherwise, you have to work with the assembly code, which we'll get to, and that's a good skill to have, but most of the time, if you can, you'd rather work with the source code. So here's all the commands that I've ever used. It has a lot of commands, but I only use a few of them. Break sets a breakpoint, and run runs the program until something happens to make it stop, like it ends, it crashes, it hits a breakpoint, or it stops and asks the user for input. Continue continues after a breakpoint, and quits, of course. Next takes the next line of source code. By the way, next I does the next line of assembly code. And steps through the next line of code, and this steps into the function and pauses. List source code and prints out variables. Where prints the call stack to show you how I got here. What routine called another routine, called another routine. You might be several layers deep. You usually are when you're working with C code. And frame moves into the context of a specific stack frame. You only use that in special cases. So let's take a look at this bad program here. If I do ls, I've got bad program here. Let me make this bigger. All right. So, all right. So if I cat bad program, all right. So what you got here, you got a function that should find the largest element in an array. So you pass it a pointer to an array, which it calls array1, and then it looks to see if or if array1 is null, so it is not null, or the length is less than or equal to 0, then give up. You can't do anything. Otherwise, set the maximum to array1 sub 0, and then loop through each array element up to the length here until you find the largest value. By the way, I'll mention this construction here is quite dangerous, and this is what led to the Heartbleed vulnerability in Linux. You take the length as a parameter instead of looking at the array and seeing how long it is. That's what the Heartbleed vulnerability did. If you lie about the length, you can end up reading or writing past the end of an array here. Anyway, the other flaw is, of course, it never returns anything. And it doesn't change any value in array 1. So that's clearly a problem. There's no way for the result to leave this routine and get back to the main routine. And the main routine, you can see, here's an array to work with, and the largest element is at the end, but it's going to call find and return max, and it's not going to show them. It's expected the max value to be max, which would be array sub 0. So apparently what they expected this to do was to set array sub 0 equal to max, but it never did that. So there's a few flaws in this program. All right, and we'll see how you can. So if you run bad program, the right answer is 60. But it gives you 17 because it's always going to return the first element of the array sub 0, since it never does update anything. Let's see, is anyone here? Yeah, it's jail. All right, good. Hopefully he sees his answer now. All right. And by the way, let me check and make sure the sound is going out. Yeah, it is. Good. All right. So let's try some tricks here with GDB to watch this happen. If I run the thing in GDB, all right, and the Q just makes it quiet so it won't print a big ugly banner. And I break main, and then run. This will start it and stop right at the start of main. So right at the first line, and it shows me the source code here. here's where it sets the end of the array. Now I can list and show some of the lines. Here's main, here's the first line, and there's more lines after it. And I can also list the routine, list, find, and I thought it might know the name, but it doesn't. Won't let me do tag completion. But there, I can list this function. And here it is at the start of the function. It does something like the first 10 lines by default. And so if I do next, it'll go to the next line of source code, which moves from this one to that one, skipping the blank line. And then I can see now it has set max equal to something, so I can print the variable max, see what it looks like. And right now it contains 0, which is a little strange. Array should have 17 in 0. At this point, oh, because it's on that line, it hasn't executed that line yet, that's why. If I do next again, then it executes that command, and now if I print max, now it contains 17, all right. And if I go to the next line after that, it's going to call find and return max in the next line. So that'll be next. And that's going to, so next does what you call a step over. It calls this routine and goes to the next one. Let's make a bigger list. Let's list, say, 1 to 20. All right. And nope, got to do more. All right. Let's do list 1 to 30. List 1 comma 30. All right. And now, I just didn't get enough. All right, let's do list 135. All right, there we go. This is what I wanted to see. After it calls find and return max, 17, then int, oh, this, main is way down there. Okay, let's list 33 to say 50. There we are. And this is the point. We executed this command and it was 17. Then we executed this command, and if the program was working properly, it would change to 60, and we end up down here. So next went to the next line at the current level we're in. So it went into the subroutine, ran the whole subroutine, and came back. And that's what they call a step over. And that'll be important as we go ahead in assembly debugging too. All right. All right. And so the max is still going to be 17, and it never changes at all. And so that's the clue that something's wrong here. So if I can delete the breakpoints, that's what this will do. Yes. And then I can put a breakpoint at find and return max. All right, and now I can run to that point. Because we skipped through this program, we didn't see what was going on inside there. So now I can list that function. All right, so now I'm in here, and my breakpoint stopped at line 21. So it stopped in here. The first line that actually will do something in this program, other than allocate memory. And now I can display a break 26. If I look ahead, let's list 20 to 30. All right, so 26 is down here. And so I'd like to break inside the loop so I can examine the value of this variable while loop runs. So I break at line 26. And now I can display I, display max. Now, before I used print prints the value of a variable once. Display will print it every time you break. So display I, display max, and display array1 sub I, okay? All right, and now I can do continue to loop through the function. If I continue, okay, so now I is 1, max is 17, so it sets it as the first variable, then it looks at the next one, which is 21, and next time it looks at 44, but the max doesn't change. Well, the max does change. The max is correctly calculated. Now the max is going to be 44. Now it's going to net for 60, and it's going to set the max equal to 60. So it is calculating the max pretty well. The problem, now the next thing is we're going to see the loop goes too far. It continues, it looks beyond the end of the array and finds this 0. So that's screwy, and if there happened to be a large value there, because that's unallocated memory, we could have the wrong value for the max. But anyway, it returns, it always prints 17 even though the max is 60, and that's because it doesn't pass the variable back to the main routine. So, all right. Anyway, that's the point, max is not passed back to main. All right, so that's one simple case to examine. Another one is this segfaulter. If I cat segfaulter.c, you'll see here I have an init function that just sets the arrays to a list of integers. You pass in array and length again. Again, this dangerous construction where the length could be wrong. Here I have a func, and the func looks like it also just sets the array to various functions. In fact, this init function, this func, if max, so this finds the maximum and then fails to return it, okay. And this main calls the init func and then calls the func to find the maximum and then prints out what it thinks the maximum is, which would be the third value in func, max here. Oh, okay, this is actually okay. Oh, or how do you guys think? Is this going to work or not? Any comments? I pass in a variable max, I set max equal to the value, and then out here, I'm going to pass in max and then print out max. Is it going to get that from the subroutine or not? No votes. Let's try it and see. All right, we'll see as we go ahead here. So I've got it, and I'm just going to run it. If I run it, I get a segmentation fault. So something is seriously wrong with it. And does anybody see why the seg fault is there? Well, take a look at the array. The array is pointer that's null, and you never allocate any space for it. You try to use it by just having a null pointer, and you can't do that. The address null is not legal, so it's going to crash because you never allocated any room for it. All right, so if I put it in debugger, GDB, and then run it and see where it crashes. It's going to crash, and if I want more information, I can do where to see the stack trace, and this tells me it was in main, and main called init function, and it crashed in init func on line 14. It was called from at line 14. All right, so now I can do a list, and here's line 14, so it crashes right here. So it runs until I call this function. Until this function tries to put some data in the array, this is where the null pointer dereference happened. It tried to store some data there, and this is a null pointer, so it will crash. All right, that's the null pointer dereference. All right, and by the way, another flaw, it's not going to return a value from that subroutine. Let me get out of here and go back to looking at source code. All right, if you pass a maximum to a function like this, it makes a copy of the value of this, and it puts it in a local variable int max. This int max only exists inside this function, in this region. So when this function stops, max is just left on a stack frame that's going to be overwritten. It never passes it to the calling routine. If you want to pass anything in the calling routine, you either have to return it here, or you have to pass in a pointer to it, so the function can continue to use the variable. If you pass in by value, any change you make in this will not go to this calling routine. So that's another flaw with this program. All right, anyway, all right, so there's a lot of keyboard shortcuts. Tab will complete a command. Up and down will repeat previous commands, and the same thing happens in a command line environment anywhere, pretty much. Return repeats the previous command, which is unusual. That's a feature of GDB. And so here's the common commands. Help will give you a lot of information about commands. Break sets breakpoints, run runs, continue continues after a breakpoint. Step goes to the next line of source code, and next goes, so this is step into, where the next line of source code, and if it's a call, you'll move into that function and stop at the first line of the function. Next will stay at the same level, so if you call a function, it'll run the function and return. So this is what you call step over in assembly language debugging, and this is what we call step into. And so until will run up to a line number, quit will leave the program, list shows source code, where shows the current stack frame to tell me which routine am I in and how did I get here. Frame moves into the context of a stack frame. You only do that in advanced things. And there's a lot of ways to affect breakpoints. And you can set conditional breakpoints, where you have some kind of mathematical condition to decide when to break. I've never had to do that. I only do relatively simple things. Print prints the values one time. Display will keep printing the value at every breakpoint. X examines memory. We're going to use that one a lot when we get to assembly code, as you've done it before already, I think. And what is shows the data type of an expression. We're not likely to worry about that too much here. And sets a value. Info shows a lot of information. The main one we use is, well, there's a couple of infos that are interesting. Let me get in here. If I get in here, the one I like is info proc map. Right, okay, I have to, let's step in. All right, let's put a break at main and run. And now it should be running. Okay, now I can do info proc map. There, this shows me the memory allocation for this program. This will be quite useful, especially when we get later. It shows all the regions that are reserved for it. And another one I like is info, I think it's registers. Yeah, we'll use this one a lot later. It shows all the registers in the processor, which are used to find the stack frame and such. And we've done that a bit in the projects. All right, let's try a Kahoot. (3A). That's 13A. There's 3A, all right. Several people in Twitch, all right. Good, you can see the number. All right, so which command will execute the next line of source code without stepping into functions? That's next. Step steps into, next steps over. All right, which command displays C source code? That's list. List is what shows you source code. Print shows you the value of variables. All right. All right. Which command automatically displays a variable at each breakpoint? That's display. Good. All right. which one will cause a seg fault? This one does, but that one also does. Writing to unallocated memory. This is a defective question. I can't change it now. I'm going to make a note to fix it. Anyway, yeah, that one should also be right, but there's nothing I can do to change it now. That's part of why these things are extra credit. They are somewhat buggy. Anyway, this is chapter 3A, last coot. Wrong. Let me make a note so I can fix it. But anyway, we'll go with today's winners. Carry on. So, val grind will let you try to find memory flaws. Mem check is, yeah?
I do not see my name in Gabo.
What's that?
I do not see my name.
Yeah, that means you weren't one of the three winners. You were there, but yeah, only the three top scorers get it. Yeah, good, okay, good. Yep, it's good to know. And it grades you both on accuracy and on speed. So there's 1,000 points for each question. Okay, good. Anyway, so val grind has mem check, and that will look for heap memory errors. Like here's a reading from uninitialized memory. You've only made enough room for one integer, but then you try to read the third integer past that. All right, and setting a value at an unallocated location would do it. So I define pointer 11 equal 100. That's unallocated, and here I read from it. All right, so those are various things you might have go wrong. And there's heap memory errors, like if you free the same thing twice, that's very dangerous. That can lead to someone taking over your machine, so it should warn you about that. And here is a memory leak when you lose the address of a chunk of heap space. So here you define some heap space, and then you use the same pointer to point somewhere else. So now you've lost a reference to this area, and you can't free it. And this is what uses up the memory and causes your program to crash. Windows 95 was famously burdened by heap overflows. And so what happened is if you were using Windows 95, every 2 hours you would die with the blue screen of death because it would use up memory, not return it, and run out of memory. And Microsoft, it didn't fix it until Windows 98 second edition. So for years, Windows was that way. And Microsoft added automatic save to Word because your Microsoft Office would just crash every 2 hours and lose all your stuff. So anyway, all right. So Big Fish is one that's going to crash when it tries to free Little Fish. So let's take a look at it. Well, here it allocates space for two arrays. Here's Big Fish allocates some space, and Little Fish, it allocates some space. All right. It checks to make sure that it didn't get any null pointers. Then it puts some data in them. Then it prints them out. And here's a bad heap memory access. It's now going to set after the end of 10. The array only goes up to 10. Really, I think it only goes up to 9. And here it's going to go up to 12. So it's going to write a couple of data points off the end of the array. And then it's going to print those arrays again, and then it's going to try to free them. And the point is, heap memory has some control structures at the start. At the start, it has a pointer to the previous chunk and the next chunk. Then it has the data. Then it has the pointer of the next chunk's forward and back pointers. So when you overrun the data section of a heap element, you change the pointers that point to the previous and next chunk. And when you free it, it uses those pointers. So it's going to write data there, and then it's going to try to use them for addresses. So it should crash at one of these free statements. When it tries to free one of these, it's going to try to use pointers to memory that are no longer valid. They're going to have some number like 66 plus something small. So let's try that. If you run it, let's see where it crashes. Here. So I get out of here, and I do a list. I'll see I do have Big Fish here. So if I run Big Fish, okay, it defines the array. Here they are. 10 to 19. Then after the loop, it makes this one bigger, and it ran off the end of it, so it changed the first element in Little Fish to 78. This Big Fish ran off the end and changed this, but it also changed the pointers. So when you try to free it, it's going to crash because the pointers you stomped on with 76 and 77 should have been pointing to valid memory regions, and now they're pointing to ridiculous low addresses 76 and 77, so it'll crash when it tries to write or to those locations or read from them. All right, and all right, so you can use valgrind, and I think I will just run, if you do run valgrind, it will go through and then it will say invalid write, tell you you're writing off the end of an array, and it'll tell you here what's going on. So it does detect that you wrote off the end of an array and warns you. All right. And so there's advanced features, but we don't need them. The basic GDB features are fine for what we're doing. But debugging assembly code is what we're going to do a lot in this class. So let's try this one, Simple Ops. I think I need to download this one. All right, let's see if I have it. I do have it, all right. So I've already got it and compiled it. All right, and I made 32-bit code. So let's debug it. All right, and I'll do break main run, okay. And run, and I want to get rid of the colors, enabled, off, right, and then I can list main. Oh, that's rude. Oh, disassemble main, right. See, I compiled it without the -G switch, so I cannot refer to source code. I have to do assembly code, and you do that not with list, but with disassemble. All right, so here's the assembly code that runs it. The arrow tells you your current command. So this is where it stopped, where it's entering it. This is just preparing to run it. And now it's going to do some things here like move and multiply and add. All right. And there it is, yep. And so now we can set a breakpoint in raw memory here, not by the line number, but by just an address. And then we can execute the next instruction. And this is the step into. This is next to step over, and this is S to step into. And we can use display to automatically display values and info registers. So, all right. And so I could play with that here. Let's try that stuff. So if I put a break, let's see, is there a loop here? I don't see a loop. So I think I could just go step by step here. All right. I think we're not going to do anything more than just look at it for this one. All right. Anyway, there is a graphical debugger. You can take a look at it. Like I say, I didn't waste my time on it. I'm not very interested in it. And we don't need to debug multi-threaded programs. We don't need to go there. We'll deal with that stuff later in the class. Anyway, so let's try last Kahoot. And then we got a demo, 3B. And you've already done some assembly level debugging in the projects, and we'll do quite a bit more. So, that's what you have to do in malware analysis. All you have is the assembly code. You don't have the source code. So you have to get good at assembly code debugging. All right, so if you don't call free, what happens? That's a memory leak. You allocate memory, but you never free it, so that memory is just gone. And if you keep on doing that, sooner or later you'll make your program crash for running out of memory. All right, So which command displays assembly code? That's disassemble, kind of logical. Display prints out the value of variables. Disassemble is what shows you the assembly code. All right, and which one is a graphical debugger? All right, GDD is a graphical debugger. All right. All right, let me stop this one.